Hey everyone, so in this video we are going to define an operation on two sets called the Cartesian product. And so if we have a set A and a set B, then the Cartesian product is a set of all ordered pairs where the first element x comes from set A and the second element y comes from set B. And one example that you are probably familiar with already would be r cross r, which is just the xy plane. So this would consist of all points whose first coordinate is real number and whose second coordinate is real number. And so r squared, this is just another way of writing the Cartesian product of r and itself. Okay, so let's take a look at this example in one. So let's say we have one set A, which is the closed interval from 0 to 2, and we have a second set, which is a closed interval of values from 1 up to 3. And we want to draw the set of A, which is the interval from 0 to 2, closed, cross B, which is the interval from 1 to 3, closed. And so this is going to be some subset of r cross r, of R2. So we can draw the plane over here. So all of these points would be R2. And now what we're doing is, let's just say we have 0, 1, 2, 3, 4, 1, 2, 3, and 4. Then we're taking first the interval from 0 to 2. So that would be all of these values over here. So that means our first coordinate x has to be some number between 0 and 2. And then the second value in the ordered pair, the values for y in this case would have to be any number including from 1 up to and including 3. So altogether, we have all x values are going to be between 0 and 2. And all of the y values are going to be between 1 and 3. So altogether, this region would be the closed rectangular region consisting of all of these points whose x-coordinate is between 0 and 2, and y-coordinate is between 1 and 3. And thus the resulting Cartesian product is a closed, bounded region inside of here consisting of all of the points in that red region. And one thing to point out before we move on to the next example is in this one, both of these sets were continuous ranges of values. So they consisted of all of these points in here and all of the values in here. So on the next example, I want to take a look at what happens when we take the Cartesian product of two discrete sets. And so now let's consider a set A which just consists of 2 points, 1 and 2, and not the values between 1 and 2. And we'll let set B consist of 3 elements x, y, and z. And so let's first list all of the elements in the set A times B. So in A times B, this means all of our elements in this set have to have the first coordinate in the ordered pair 1 or 2. So I have one element whose first coordinate is 1 and second coordinate is x. I have a second element whose first coordinate is 1, second is y, and we get one of these. And then we similarly get 3 more elements when we pick 2 as the first element in the ordered pair, and then we have x, y, and z for the second. So we can see that this set consists of 1, 2, 3, 4, 5, 6 elements. 6 ordered pairs are in that set. And let's see what happens if we switch the order in which we take this Cartesian product. So if I take a look at the set B cross A, now what happens is the first coordinate in this ordered pair should come from the set B. So for example, I could have x as the first coordinate and then some element from set A, such as 1, as the second coordinate. So I would have 2 elements that have a first element of x, x comma 1 and x comma 2. And the same goes for each of the elements in B. I would have 2 corresponding elements in B cross A, y1 and y2, and then we have a z1 and a z2. And so one observation to make here is that the order in which we take these products in general does matter. So for example, the element 1 comma x, that happens to be in the set AB, but 1 comma x is not an element of the set B cross A. So this tells us these two sets are not in general equal to each other. And so let's consider the following claim, and let's see if we can prove or disprove this claim. So the claim here is for sets A and B, A cross B is equal to B cross A. Well, we just disproved this. See previous slide for a counterexample. So it is not true that these two sets are equal to each other. So A cross B is not equal to B cross A, and we saw that on the previous slide. Okay, so we'll work some more with Cartesian products and proof and disproof with some properties of Cartesian products in class.